Good morning, dear students. Myself, Dr. Priya, working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. So, in today's session, we are going to learn about various factors that are responsible for influencing rate of corrosion reaction. That means they will show their influence. That means either there will be an increase in rate of corrosion reaction or there will be a decrease in the rate of corrosion reaction. Let us see one by one. There are two different factors that are responsible for influencing rate of corrosion reaction speed. One is nature of the metal. That means with respect to metal and its nature, there is a chance of influencing the speed of corrosion reaction. And the second one, it is with respect to the environment, or we will call it as surroundings. Basing on the nature of environment or surroundings, rate of corrosion reaction will be altered. So let us start with the first one, that is nature of the metal. So these are the different factors which will come under nature of the metal, that is position of the metal in the galvanic series and the relative areas of anode and cathode parts, purity of the metal, nature of a surface film that was produced, nature of the metal oxide film that was produced, and then physical state of the metal and solubility of corrosion products, or we will call it as volatility of the solubility products. So let us go with first one, position of galvanic series. Position of metal that is present in the galvanic series. So in galvanic series, hydrogen it is considered as a reference one because whose potential it is arbitrarily fixed as 0. And the metals which were placed in highest position in the galvanic series, that means above hydrogen, whatever be the metals that were present, they will act like more anodic or more active metals. These will involve in corrosion reaction very fastly. That means if the metal which is placed in higher position in the galvanic series will undergo corrosion reaction usually. Metals which were placed below hydrogen will be considered as more cathodic or noble in their behavior. That's why they doesn't involve in any kind of corrosion reaction. If the metals are anodic in nature, then rate of corrosion reaction will be increased. If they are cathodic in nature, rate of corrosion reaction will be prevented. And coming to the next factor, that is relative areas of anode and cathode. Just now we discussed about wet theory of corrosion. In that we come across with anode and cathode areas. If anode area is large, then rate of corrosion reaction will be less. If anode area is small, then there is a scope for corrosion reaction to take place in a faster and continuous manner. So if you notice this relationship, this rate of corrosion reaction, it is directly proportional to ratio between area of cathode to area of anode. If cathode area is large, then rate of corrosion reaction will be high. If cathode area is small, then rate of corrosion reaction will be less. So coming to the next factor, that is purity of the metal. If purest form of metal it is considered, then there is no question of corrosion reaction to takes place. That means somehow we can prevent. If there are impurities like welding, we have to join two metal blocks, then we have to depend upon several methods. Among those, welding is one kind of method in which we have to make use of impurities. So in such kind of conditions, there is a chance for formation of electrochemical cell on the surface of the metal, so that corrosion reaction will be increased. So if more pure the metal, less will be the rate of corrosion reaction. Here one example it is mentioned, that is the purity of zinc. It is 99.999%. If the corrosion rate it is 1. And if purity is going to decrease, then corrosion rate is going to increase, if you notice. So here it is more, then corrosion rate is considered to be 1. If it is 99.99% only purity, our remaining percentage we have added impurities, then it will increase to 2650. If it is reduced, that is from 99.99 to 99.95, that means 0.5%, 0.05%, sorry, 0.05% we have added impurities. So remaining all it is purest form of zinc. In that case, rate of corrosion reaction it is proceeding in a faster manner, that is at 5000. So if more the pure metal it is considered, less will be the rate of corrosion reaction. What is the next factor? Nature of the oxide film that was produced. So surface film, basing on the statement of filling word rule, we have already studied at a specific volume ratio. If it is greater than 1, then it will act like a protective film. If the ratio value it is less than 1, then the surface film produced will act like a non-protective film. For example, if you notice the specific volume ratios of tungsten, chromium and nickel, like 3.6, 2 and 1.6 respectively. So, which is having more value? Tungsten. It is having 3.6. So, corrosion reaction will be less in the case of tungsten when compared to nickel and chromium. Next one, it is physical state of the metal. Solid metals. That means if any kind of a stress it is not involving. Metallic surface, if it is not involving any kind of stress. That means if any stress is there, like bending and then twisting. If any such kind of changes if you did on metallic surface, then alignment of molecules inside the metallic compound will involve in destruction. That means proper alignment will be there for solid metals. Properly they were arranged inside the metallic compound. Once if it is going to disturb, then it is converting like a weak place or weak part of the metal. So it will convert into anode. As a result, it involves in corrosion reaction. So if it is having more stress, rate of corrosion reaction will be more. Less it is involving in stress, rate of corrosion reaction will be less. Next, solubility of corrosion product or volatility. Solubility of corrosion product means if corrosion product it is able to involve in dissolution in the medium. If it is able to dissolve in the medium, then new ions will be produced. Then it is able to increase the scope of rate of corrosion reaction. So, if it is insoluble, then it is able to reduce the rate of corrosion reaction. So, coming to the next factor, that is nature of the environment. First one, it is nature of the metal, and the next factor which is able to influence the rate of corrosion reaction is nature of the environment. Under this heading, we are going to discuss about temperature of the environment or surroundings, content of moisture or humidity that is present in the air or surroundings, and then pH, and then presence of impurities in the atmosphere or air. So, let us see with temperature. With the increase in temperature, rate of corrosion reaction also gets increased. If it is for the case of moisture content or humidity, so these are directly proportional towards each other. If it is getting increased, then rate of corrosion reaction also gets increased. Because formation of electrochemical cells will take place easily on the surface of the metallic surface. So, corrosion reaction takes place up to a greater extent. So, and then effect of pH. As I told you, if medium is an example for acidic environment in wet theory, that means pH if it is less than 7, then there is a chance for increase in or speeding up of rate of corrosion reaction when compared to the neutral, aqueous medium, or we can say basic medium. So, if you notice, generally in acidic medium, that is pH less than 7, which is more corrosive than alkaline and neutral, or we can say neutral or aqueous medium. In basic medium, some metals like lead, zinc, aluminum, which are able to form complexes. Hence, they also involve in corrosion reaction. So, when compared to basic medium, acidic medium is having lot of influence on rate of corrosion reaction. Say for example, zinc, we notice the pH is at 11, corrosion reaction will be less. So, if it is going to increase more, corrosion reaction will proceed in faster manner. Say for example, if its pH value it is 5.5, it will involve less in corrosion. Next one, it is presence of impurities in the environment, or we can say atmosphere. Atmosphere, it is contaminated with gases like oxides of carbon, sulfur, hydrogen sulfide, sulfuric acid, H2SO4. If these kind of impurities were present, or if you say any kind of suspended particles are present in the vicinity of any industrial area, so these are responsible for imparting electrical conductivity, thereby increasing rate of corrosion reaction. In today's session, what we have discussed is factors that are responsible for influencing rate of corrosion reaction. In this, we have two different factors. One is nature of the metal, and the second one is nature of the environment. So, in this, we have factors, various sub-factors we have discussed so far. So, in the coming session or in the next session, we are going to learn about types of corrosion reactions. How many types of corrosion reactions are there in the nature? So, that's all for today's class. Thank you very much. Have a nice day.